A-level revision video here. We're going to be doing A-level chemistry with our master mathematician and A-level physicist. And who knew, A-level chemist Tom Evans on the show, back again for the third time.
Loving to be back yet again.
We're going to start off doing electron orbitals.
Nice.
And how do you feel about that, Tom?
I'm buzzing to learn, Sam.
That's what a coincidence, because at the same time, simultaneously, I am also buzzing to learn.
Kieran, come on over, we're going to learn some electron orbitals. Alright, this is obviously the periodic table, and it's split up into orbitals. You might not have seen this before, because back in GCSE we were working with the assumption that the electrons were in shells in atoms in the configuration 2, 8, 8, 16 onwards. Now we have as we are in A level, we have come to the realisation that that is not the case. They're split even further into orbitals, and as you can see on this sheet here, these are the separate orbitals that the electrons split up into pairs. So one is up and one is down, is how we write it. And I'll give you a little example so you can get your head around it. This is the element of oxygen. Its mass number 16 and its proton number is 8. As it is a neutral atom, it will also have 8 electrons. So this is how we would configure it. Here we are. This is how we write it. There's 2 there. This is in the 2s block. That makes 4 electrons. Then it goes into 2p. That's 5. And one thing you've got to know, that's 6, 7. That it will always fill up the empty shells first before it starts to double up. So that's 1, 2, 3, 4, 5, 6, 7 and 8. So that is how oxygen would look. And if you asked to give the electron configuration of oxygen, you would write 1s2, 2s2 and 2p4. That's how you do it. You add it all up, and that adds up to 8, as oxygen has 8 electrons. That is pretty much how it works.
Okay, so I'm just going to go and do the same thing Tom did, but we're going to write out for copper and an iron plus ion. So copper, 64 mass and 29 protons. So it's going to have 29 electrons. But the thing is, for copper and chromium on the periodic table, they're different, and I'm going to show you why. So you might imagine that because it's got 29, it will fill up. You start filling them up one by one, and you go up 1, 2, 2p, 3, 3p, and you do until you get to 4s and 3d. For copper and chromium specifically, it'll fill up 3d first before 4s because of the way the electrons are arranged. But for other elements, it will fill up 4s first as a lower energy. So because we're doing copper, we're going to start filling up these. You should be filling them up one by one because electrons repel each other. And then you should get to 29 electrons in total. And so we'd write that here as 1s2, 2s2, 2p6, 3s2, 3p6, 3d10 and 4s1. The whole of copper there. For iron plus ion, it's essentially lost an electron, that's why it's gone +1 charge. So iron has an atomic number of 26. So if we just draw out 1s2, 2s2, that's 4 electrons, 2p6, that should be 10, 3s2, 12, 3p6, 18, 3, it will start off filling up with a 4s, wouldn't it? So 4s2, getting to 20, and then it adds on 6 to the 3d6, So if it's lost an electron, it's going to lose one, but is it going to lose one from this shell or this shell? Because this is the outermost shell here, 4s, but this is the higher energy level. What it's going to do is it's going to lose one for the outermost shell, and so this 2 would turn into a 1 instead for a copper plus ion, and that's what happens as you ionize and show the configuration.